Alright, time for another draftphysics.com video presentation. Debate physics also, but as stated, no debaters worthy of any kind of even mention, barely. So, yesterday's Feynman video. So I think I'll put this video on YouTube just because I'm going to, pick on Richard Feynman. Because, yeah, his physics was not good physics. It wasn't good logic. And, he has this reputation as being the science guy, and it really is shit science. Like that other guy called the science guy, or whatever the fuck he's called. It's kind of just bullshit. Anyway, so here's the comments. Crap. Okay, that was great. Yes, very insightful. Thank you so much. Fuck off. I mean, too ridiculous. All right, so you know what? I point out as I'm watching the video, okay, I see in the background there's a painting of a cosmos, a globular cluster, and an image of a guy smoking a cigarette. And, yeah, my guess was it was Richard Feynman, but I'm saying Richard Feynman wasn't a astrology kind of guy, cosmology. He wasn't the big universe. He was the little universe kind of guy. Alright, he got his Nobel Prize for Feynman diagrams, which are about how electrons and protons and muons and puons and all the little bullshit act. And, most of the dominance of his lecturing, okay, his books, which I've read, more than one of them. I read the book about his whole little story of going to went to some little town in Russia or something to find the golden chalice or something. I can't remember what he was looking for. Anyway. So yeah, I'm very familiar with Richard Feynman. Okay, seen a lot of Feynman content, and that's who I would have guessed. But it just seems so wrong for somebody to put Feynman's image in a Carl Sagan background. Carl Sagan was big space. Come on, cosmos. Richard Feynman was not cosmos kind of physics. Anyway, So this asshole leaves a link to Richard Feynman. Like, I don't know who Richard Feynman is. I've done many videos playing Richard Feynman's videos. So again, just such bullshit. Because I didn't think it was a very good painting also, right? And Richard Feynman's appearance changed rather dramatically. So I'll show that because I want to play two clips from 20 years difference in time. And you can see for yourself that he's hardly recognizable. If it wasn't for his voice, you wouldn't say it's the same guy. Alright, so anyway, so that's the extent. So Feynman Dan did leave a regular comment from his own. I had accidentally left the approve comment thing on. That's the default. I have to change it, so I probably will change the default back to allow comments. But anyway, so I had to switch it later. So I guess he just thought his comment wasn't going through. But he left the same comment from both his channels. So it really points out that he's paying attention, which is funny. Okay, he's paying attention to the videos, but he just couldn't care about the actual content of the video. The actual accusations made against him, he won't refute or won't answer. Okay, that he's a greedy whore. Okay, physics. He's using physics to whore for an income. That he's doing it by basically finding the easiest targets you could find on the internet. What did the dopiest person say today on the internet? I'll take advantage of that and do a fail video. It's so, lame to pick on such easy little targets. Pathetically lame. And then this is what he says. Amazing. You call yourself draft physics. Yeah, it's draft physics. It's not I love your icons physics. So even if I didn't know who Richard Feynman was, it wouldn't change anything about having the title draft physics. But anyway, and you can't even identify Richard Feynman in a painting. So it's a painting? Somebody painted the cosmos and then painted Richard Feynman in it? And that's the person who knows Richard Feynman better. So if you really think that if Richard Feynman was going to be identified with a background that he would choose a galactic cluster because he was a galactic cluster expert? And that was his subject. So it has nothing to do with his Nobel Prize. His Nobel Prize was a math trick. Okay, and it certainly doesn't have anything to do with the substance of his lectures, which are about kind of the fact, it's all kind of Newtonian, except Newtonian is really random. But it's photons. I mean, he's most famous for photons, understanding photons. I mean, get real. So you're the one who doesn't know Richard Feynman. And then the other guy, just points out the biscuit thing, and I was going to say the same thing myself. I don't know exactly what that means, but whatever. Everything in the video, you're going to say exactly the same thing? Amazing. Anyway, whatever. I mean, yes, I understand. You don't have much time. You can't comment very, I don't know, irrelevantly. So you just comment affirmatively. Okay, thank you. I'm struggling saying thank you, of course, just because this isn't what I want out of this channel. I want to find the discourse, the proper amount of, point counterpoint, some kind of rational, reasonable conversation that has some sort of value, arguing about the meaning of a biscuit and, whether a Feynman painting really represents Feynman. It's just such bullshit. All right, so let's go to the Feynman videos. All right, so here are the two lectures that Richard Feynman gave. So one in 1964, the other one in 1981, I believe. Since 81 or something like that, pretty close. 79, 71. Well, anyway, doesn't matter. They're a while away, 20 years almost, 15 years difference. So a series of lectures. They're very good. I liked Richard Feynman, frankly. I liked his style. He's kind of quirky, kind of strange. But obviously his appearance changed rather, I think, kind of substantially. I mean, he lost weight and changed his hair color, blah, blah, blah. I mean, his appearance was quite different. So I have to admit, this is more the Richard Feynman my brain thinks of than this Richard Feynman. But whatever. Okay, so we'll come back to this video. We'll do this one first. And okay, I'll speed up just a little because, frankly, we only have so much time. Well, this video is playing in picture-in-picture mode. I didn't click on that. Oh, I gotta fix that. Alright, should be back. Oh, let me just fix this again. It's okay. Playback speed's a little tiny bit faster. Alright, so this is a little speech by Richard Feynman talking about, how you do this science thing. So I just want to put this against the fact that in his... So this is years after his previous lecture when, in my opinion, he was pretty much completely, deceptive in how he described the reality. I mean, he cheated it profoundly.
You don't understand because... Say the languages. The fellow comes from America and he talks too fast. That's my fault, and I apologize. I hope it's all right. That's a kind of trivial difficulty, relatively. The next kind of not understanding is because you perhaps use new words. That's an accident that comes because I'm working technically, and I use the words every day, and I forget that everybody doesn't know what they mean, and I have to be very careful. Again, my job. And then there's a kind of saying that you...
So this was my fault. I should have, I wanted to link to a little further in here, and so when the video switched, it put the time back at the crappier time. So, sorry.
You don't understand it, meaning I don't believe it, it's too crazy, it's the kind of thing I'm not going to accept it. The other part, well, this kind, I hope you'll come along with me. You'll have to accept it.
So you'll have to accept it. You have to, because the evidence is overwhelming. Because we've all been we're very smart and you're very stupid. So you have to believe. So even though it makes no sense. So again, he might as well be talking to Einstein. So Einstein was dead by now. But he might as well be saying this to Einstein. Too bad you don't like it. Too bad it doesn't make any sense. Too bad it sounds silly. Too bad it sounds like we're going right back to religion again. Too bad.
Because it's the way nature works.
No, it's not the way it works. It doesn't work by your rules, your conclusions, okay? It doesn't. You've interpreted the evidence really badly, and you show how badly you're capable of interpreting the evidence because when you describe the evidence, you describe it outrageously inaccurately. Okay, you don't give it any. You're not honest to the actual facts. You're honest to a story you've told about the facts.
Want to know the way nature works? We looked at it carefully. Look at it.
So we looked at it carefully. Now I'm going to show you his analysis of the most famous photon energy experiment ever done, the famous two-slit. And he does it so badly, and it created my own confusion. I mean, I was confused on the subject for 30 years because I believed the fable they were telling rather than recognizing that maybe I should go look and see what the experiment actually does. Instead of listening to their story, because their story, yes, they can tie it into something. But if you actually look at the actual facts, it's clear, oh, there's a lot more to this story. There are details they're just ignoring, and they're really important details. Like the detail that they haven't repeated the Eddington experiment from space, where it's much cheaper and much easier to do.
That's the way it looks. You know,
So that's the way it looks. That's the way it seems. That's the way we've all concluded it is. So if you don't like it, tough.
don't like it, go somewhere else.
So in the same series of lectures, he says this again, but he says, tough. If you don't like it, tough. The universe is random. So he premises it with the Einstein kind of argument that, of cause and effect. So he basically says, I'm breaking cause and effect. I'm telling you, cause and effect is not a reality. All right, the fact is that I can set up the universe exactly the same way, and the outcomes will be different. So he might as well say, I believe in free will, whatever the fuck that would be. He at least believes in random will, whatever the fuck that would be.
To another universe where the rules are simpler.
Yeah, so this is his attitude, right? And so this is good for science, this kind of arrogance, and it's really pretty obnoxious. And again, in another portion of the same video, he's answering a question, and he basically says, you're all too stupid, okay? You're not going to come up with a better answer than our answer, because we're really smart, and we've looked at it, and this is the only possible conclusion. There's a random God. It's really pitiful.
Philosophically more pleasing, more psychologically easy. I can't help it, okay?
No, something that's logical and rational and consistent with the evidence. And the fact is that your dualities and your silly, idiotic, cobbled together answers because you want it now. Okay, so you're the one showing huge impatience. It's big pressure here. We're all searching for our Nobel Prize. We got to come up with an answer. So you're forcing answers that suck. And somebody who recognizes that, you're suggesting they have to go to another universe because this is the universe where people make mistakes all the time. They're not careful and they fucking draw wrong conclusions. That's this universe, okay? We got plus and minus wrong 200 years ago and we didn't fix it. We got energy way wrong 300 years ago and we really aren't going to fix that one.
If I'm going to tell you honestly what the world looks like to human beings who have struggled as hard as they can to understand it.
Okay, so no, that's not what you've done, okay? You haven't struggled as hard as you can because your absence of detail, I mean, the fact that you have, missed so many details means you couldn't have struggled very hard. You couldn't have looked at the truth very long because you wouldn't draw it so badly.
I can only tell you what it looks like, and I cannot make it any simpler. I'm not.
So you can't make it any simpler than to say it's a mathematical equation and it's a probabilistic. God does roll dice with the universe. So screw what Einstein said again. Just, the moon doesn't exist until we look at it. Blah, 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 blah. All the little bullshitisms we have to believe.
I'm going to do this. I'm not going to simplify it. I'm not going to fake it. I'm not going to tell you something.
Okay, so he is going to fake it in the sense he's going to give you a narrative that isn't actually the truth. Okay, so in this case, in this video, he was talking about the reflection and refraction of light, and in the other video, he's doing the double slit. And so we'll play the double slit video because this one's obviously this subject's a lot longer and a lot more details. But both of them he doesn't treat fairly. He simplifies them into mush.
ball bearing on a spring. It isn't. So I'm going to tell you what I really...
Well, even when there's a ball bearing on the spring, you cheat. Even when it's a lever, you cheat. Levers are free energy devices. That's something it's going to occur to you if you do any experiments with levers. They have more kinetic energy on one side than the other. So even though they perfectly oscillate, they have more kinetic energy on one side than the other.
...is like, and if you don't like it, that's too bad. Okay?
Yeah, it's too bad. It's it's physics. We own it. It's our property. You're all silly. We're freaking celebrities. I mean, it's just so arrogant. So this was after he won his Nobel Prize, and he really became an obnoxious asshole.
There's also the possibility that you don't understand because you get a bit confused and you're sure that you must have misinterpreted what I said, or something like that.
So he's reading from his script and he's saying, okay, this is time for the joke. So I mean, all of this is just performance art. All right, he carefully constructed. He even says this. He spends a lot of time on his performance. Okay, so it sounds like it's just, I'm just doing it. But no, this is all planned little jokes, planned little points, so now he's going to make the punchline, So earlier in this very little stream of crap, he pointed out how nobody understands quantum mechanics. Okay, the students don't understand, the teachers don't understand, nobody understands. That's okay. It's physics. Who needs to understand anything?
Get turned off, and that's a cause of difficulty. But let me assure you that most of the time you did interpret correctly what I said. Because if it does, it's going to be so shocking the way nature actually works that you're not going to believe that either. I faked it. I'm not telling you the full story. That for the students, I have another way of explaining it, or something like that. It is not true. I'm going to...
Okay, so it is true. Maybe he is just as bad with the students, but it's hard to imagine, especially in the case of the slit experiments. But I mean, this is how bad the physics is. You can't have something like this 1/2 mv squared that's never been proven. There's no bulk of evidence. There's no amount of evidence showing that it takes twice as much fuel to go twice as fast. No race car driver notices it. Nobody, it's like the bowling argument. Okay, if the 8-pound ball thrown at twice the velocity has twice the capacity to do work in the universe, why wouldn't professional bowlers be using lighter bowling balls? They will not answer any of these questions that say, well, your theory doesn't seem right. It doesn't seem right. Okay, it's not like it seems this way to you. Well, it can't seem the way to me, because I'm saying, why aren't they making big wrecking balls if there's more kinetic, if you get more bang for your buck by throwing light things fast than you get throwing heavy things slow? It's just a fact of your equation. So it doesn't make any sense. It's just so bad. Like I said, I liked Richard Feynman. I can't deny I liked him. But he's full of shit. I mean, it all sounds like he's a really, he cares and he's passionate and all this crap, but his passion is bullshit. And it even came down to, even when he investigated the Challenger disaster, I mean, even that was covered in a big fake, okay? Because what really happened was there was a lowly employee who knew what happened. He knew it was the O-rings. He knew about the rubber getting hard. And he couldn't do anything about it. He couldn't say anything without being crucified. Okay, so what he did was he fed Feynman the information. He sort of accidentally just happened to have experiments in his basement when Feynman came over so he could show him and blah, 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 so he could accidentally tell Feynman it's the O-rings, okay, without being responsible for actually telling Feynman it's the O-rings, And it's, well, whatever. Just the whole thing. Everything is just so covered in fake. The whole world is just such a fake, phony place. All right, let me see if this is on the screen. It is. Close enough. All right. So this is his version of the double-slit. All right. So leave us point out the actual facts first. Some of them. A tiny percentage, and then we'll just suppose that against the crap Feynman's saying. All right. So Feynman's going to put on the board, he's going to do this slop. He's going to do blah, 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 right? Just this squiggly crap. And he's going to say, look, it makes a pattern, and on and off. So instead of even making it even close to what it really is like, which is very discrete, very, real, okay. Not like I said, they always draw it like this, because they always want to turn it into some sort of wave function. That's not what the pattern looks like. They could draw the real pattern. All right, they could show the real pattern as, orbs of light. And that's really what it's doing. Okay, so this is actually what you'll see. All right, you'll actually see this in a two-slit pattern. And the big, giant, glaring feature of the real two-slit pattern, a real four-source pattern, all right, are these omissions, the place where the light is missing. Okay, so that's the glaring feature. And what Feynman does is just annihilate that by showing a single slit and calling it the double slit. So by making the slits, their trick is they make the slits smaller than a wavelength. Well, obviously, if I make the slit smaller than a wavelength, this distance can't mean anything, because I can't make a wavelength difference. Even if I go at 180 degrees, I can't make a wavelength of difference in the two sources. So I can't have any constructive or destructive interference, because I've made 2-point sources into 1-point source. I've taken away 2 of the sources by putting them so close together. So if you put 2-point sources really close together, they don't exist anymore, right? If I have a group of point sources, well, this is only 4-point sources if I put 2 of them right next to each other. All right, so the history is that Newton did these experiments, basically. So Newton was the first one to find this phenomenon. All right, so he did this single slit, right? This is the single slit. And he did the single impediment. And these two create essentially the same pattern, and the only difference is, okay, and it's a pattern that basically is the envelope of this, right? So this is what you get, okay? All right, so you do the single slit and you just get these nodes, and you don't get any break, and they just get weaker and weaker as you go further and further out. And these two patterns, the one created here and the one created here, will have the same position if this distance is the same, the distance between the surfaces. So clearly this is about the distance between surfaces. This is the math. So Newton didn't do this math, all right? He hadn't known that this relationship exists between the surfaces, and that as you change the surfaces, you can have this mathematical connection. All right, but anyway, about how big these nodes are and where they are. But it's that simple. This is about surfaces. So this is the math. This is the math they do. And you can see just in this simple case of the huge connection between, what is this? This isn't the distance of 2 waves. There's not 2 waves coming, or, this distance. There's not 2 waves doing this. No, there's 2 sources that have a distance between them. The wave center has to be right there in the center. The distance is the center of a wave if you're going to make waves. So you have to put waves in these silly locations. So in the single slit, their math basically says make 2 waves, half over the edge of the surface, and broken here in the center for no good reason. It doesn't make any sense. So again, tough. Move to another universe. Our explanation doesn't make sense. Move to another universe, because we really don't want to hear it. We're not going to argue any of this stuff. We're not going to counter argue any of it. All right. So the point is that the double slit is just taking these 2 experiments, putting them together, and you get this outcome. Now the irony is, okay, is that again, if you take away this distance, all right, if you make these infinitesimally small slits, like in the Young example, there is no double slit. All you've created is the single impediment again, because these 2 point sources are in the same location. So all you've done is create 2 sources again, 2 sources and a distance. So yeah, their math works, but it's a single slit math. It's not going to do this. The math won't give you this pattern. The math will give you this pattern. All right. So all you do is you open up those surfaces and make them bigger than a wavelength of light, and you start getting this. Okay, and you can have 3 or 5 or 7 or 9 or, you know, the odd numbers in here. And it's an odd number because guess what? This middle one is actually 2 nodes on top of each other. But you know, it doesn't really matter. But you know, it does matter. It's sort of an important feature. So anyway, Feynman draws all this crap here on the board, and what so he's saying, okay, shoot light. The way they originally did, you put it through a surface, and then you send it to your slits, right? And so he says infinitesimally small slits. I probably should. Well, you can see that. And he just uses this really pitiful dodge of the experiment. So first he says, okay, if I shine light through, if I block one of them and shine light through, I get this hump. And if I shine light through this hump, this slit, and block this one, I get this hump. And it's such a fake, because that's not what's going to happen. Okay, these slits are less than 1 millimeter. Okay, less than 1 millimeter apart. And when they shine on the board, they're not going this way and this way. The light is going straight through, technically, okay, quite technically, if it wasn't for diffraction at these surfaces. So that's the whole point, right? The surfaces are what's going to screw up any light that creates the fringes. But I'm just saying, when you're doing it for the purpose of just talking about the experiment and what you get on the surface here, these two humps will be right on top of each other. There'll only be a millimeter of difference between them. They will not be in different locations. They'll be right on top of each other. So it's a huge deception to say this 1 millimeter pattern of two openings automatically creates light in two very distant locations, because it doesn't. All of this stuff has to happen within that 1 millimeter. Just like any, we're going to say, well, the light from this one goes here, and the light from this one goes here, and they have to be the same length. Yeah, that's only inside of the 1 millimeter on the target. Your pattern's going to be a foot or more long. Okay, we're talking about a difference of 1 millimeter in a foot. It's not even recognizable. So again, just part of the fake. It's just fake. It's not how it actually worked. It's not how it comes out. Sorry, this wasn't in the picture. Anyway, so we'll just play his distortion. I mean, that's all it's not the truth. He's not showing the real double-slit pattern. Neither did Young. Young showed something that has nothing to do with the double slit. It has to do with making the double slit disappear. It's just obvious. By their own geometric math, they can realize what they've done when they make a slit really small, that the surfaces can't be sources anymore, because you've put them in the same place. They can't be individual sources. Okay, so we'll leave us play the video.
Bullets will be caught, and we can count them. That's the detector for bullets. I don't want to have to redraw the experiment each time, so I'll label everything in this way, and then we'll be able to catch on to situations for different cases. And also, I'm going to do experiments in which I count how many bullets come into this detector, or a box of sand, when the box is here, or here, or here, or here, and to describe...
All right, so he's just talking about an old way of detecting the number of photons was to, instead of just showing the photons on a piece of paper, you can collect them, and you just have a device that evenly goes across a surface, and you're just going to measure how many collected in different locations.
That I'll measure the distance of the box from somewhere down here and call that x, and I talk about what happens when we change x. It means only you move the doggone thing up and down. All right. Now, first, I would like to make a few modifications from real bullets into idealizations. The first is that the machine gun is very shaky and wobbly, and that the bullets go in various directions.
All right, so this is part of, again, it's sort of irrelevant, but the whole theory is sort of dependent on them not knowing where the photons are going. So if they could aim the photons and shoot them through one opening or the other opening, it would be decisive evidence that the photon isn't going through two slits. So they always have to have a random source.
Not just exactly the back. And they can ricochet off the edges of the slits rather, the holes in these armor plates. And finally, well, let's say, for instance, that the bullets have all the same speed or energy if you want, but that's not very important. But the most important idealization...
Well, I suppose it is very important, but whatever, because that's phase. So obviously the only thing you're changing is the phase of the photon. So all the photons go through the slit. And the distance, all you're really saying is that the extra distance it has to travel is just a time delay in arrival. And it's when there's a full wavelength of change, it would be a full phase of change. So this would be a full phase of change. This would be a full phase of change. This would be a full phase of change. So you're going to recreate a frequency, and the frequency is dependent on phase. So kind of obviously the speed is critical to reconstructing the phase.
In which it differs from real bullets is, I want these bullets to be absolutely indestructible. So that what we find in the box is not pieces of lead of some bullet that's broken half, but we get the whole bullet, please. So imagine indestructible.
So that's the irony of Richard Feynman, is that he didn't believe in the wave theory. So he believed in the random God, but he didn't believe in the wave theory because he knew photons were corpuscular, and he makes that argument in the 1970 video quite clear in a couple of different locations where he explicitly says, I wish they didn't teach the wave theory because they don't work that way. So it is kind of ironic.
Bullets, or hard bullets and soft armor plate or something. And now the first thing that we will notice about bullets is that the things that arrive come in lumps. When the energy comes, it's all in one bullet full of bang. If you count the bullets, there's 1, 2, 3, 4 bullets. The things come in lumps. They're equal in size.
Right, and so how do you create a frequency out of clumps? Well, I guess you would do it because the clumps arrive at a different time. So right here we already have evidence that a photon doesn't arrive as a clump. It's the byproduct of stuff arriving in a sequence of clumps. And that's its frequency. Bang, bang, bang. That's a frequency. Yeah. Bang, bang, bang is blue light. Bang, bang, bang is red light. That's, but that won't even be considered as a rational explanation by Feynman.
Size, we suppose, in this case. And when a thing comes into the box, it's either all in the box or it's not in the box. It comes in lumps. More. If I put up 2 boxes here, I never get 2 bullets in the boxes at the same time. Well, if the gun isn't going up too fast and I have enough time between, you see, slow down the gun so they go up very slowly. Bing, 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 bing. Then put the 2 things here and look very quickly in the 2 boxes. You'll never get 2 bullets at the same time in the 2 boxes because a bullet is...
Okay, so again, but it would make no sense to count incidences that are happening at the same time. That wouldn't be a frequency. So again, it's really, you have to detect the frequency. Okay, the atoms, the surface is calculating a frequency. That's what it's going to reflect, is a frequency. That's what you're going to see, is a frequency. Obviously, if they came at the same time, you couldn't see them because it's not a frequency.
A single identifiable lump. I call that characteristic of the object that it comes in lumps. So the first thing about bullets is that they come in lumps.
All right, so this was kind of a major departure from everyone else's theory. So Feynman's sort of on his own in stating this, and it's just kind of funny that, this is Einstein. Okay, right now he's making an Einstein argument. But nowhere else will he continue that argument in any sense. But everybody was okay with that. It was okay for Feynman to believe in bullets and clumps, this is somehow something that dramatic. Okay, I don't need ether, I don't need waves. It's a pretty dramatic statement when all the rest of the physics needs the ether, needs the waves.
And now what I'm going to measure is how many bullets arrive here on average in a long period of time. So you wait an hour and you count how many bullets are in the can, in the sand, and average that. We call that, if you want, let's say we take a definite time like per hour and say the number of bullets that arrive per hour. And sometimes you could call that what's called the probability of arrival, because it just gives the chance that a bullet going through this thing arrives in this particular box.
So again, you're just really watching a lot of events and then making assumptions about the individual events based on what the outcomes are, which is not unreasonable, but you have to understand that it's not going to show you how the product was made because you're not seeing close enough. You're just seeing the fact that the merchandise left the store. You're really not seeing how it was purchased or stolen.
At least it's proportional to the chance. One way to measure is to measure the average number of bullets that arrive over a period of time. Now, the number of bullets that arrive in this box here will vary as I vary x. And I'm going to make a graph here in which I plot horizontally the number of bullets that I get if I hold this thing here for an hour. And I'll get a curve that will probably look more or less like this. Because when the box is...
Okay, so that's not how it's going to look. All right, that's not going to happen. And you won't get this curve. Okay. Because again, these are 1 millimeter apart, these two openings. And the substance of the light is going to go straight through. And that you're just going to get lumps 1 millimeter out of phase with each other. So they're going to be right on top of each other.
Behind one of these holes, it gets a lot of bullets. The ones that went through this hole, and otherwise it gets in the one through this hole. And if it's a little bit out of line, it doesn't get as many. They have to bounce a little off the edges of the hole. And so it disappears like this. And this is the number that we get in an hour when both holes are open. And I call that, by an abbreviation, N12, which merely means the number which arrive when hole number 1 and hole number 2 are both open. Looks like that, sir.
So it doesn't. All right.
Now, I must insist that the number that we're plotting here doesn't come in lumps. It can have any size it wants. For example, there can be 2.5 bullets in an hour. In spite of the fact that the bullets come in lumps, what I mean by 2.5 bullets in an hour is that if you run a long time, like 10 hours, you get 25 bullets. So it's on the average 2.5 bullets. The N can have any size. It doesn't have to be in lumps because it's an average. I'm sure you're all familiar with the joke about the fact that the average family in the United States seems to have 2.5 children. It doesn't mean that there's a half a child in any family, whatever. The children come in lumps. But nevertheless, when you take the average number per family, it can be any number whatsoever. And so this and measure how it moves up and down. And what I'm going to measure, in fact, is the energy of the agitation of the cork, which is exactly proportional to the energy carried by the wave.
I shouldn't have jumped that far ahead.
Some kind of a big mass of stuff which is being shaken up and down. This is a very important law, which is that the number that arrive with both holes open is the number that arrive by coming through. The number that arrive in this container per hour on the average need not be an integer. It be a tenth, which would mean under those circumstances that you have to wait on the average 10 hours more or less per bullet. So what we measure then is the probability of arrival, which is a technical measure of the probability of arrival, which is a technical term really for the average number that arrive in a given length of time. And now,
so it just encourages the idea of thinking about this as if you're rolling dice or it is some sort of randomized event, and even rolling dice isn't random. Okay, so again, the idea that random can even exist for a physicist, I mean, they should know this is not a real concept. It just looks like random. It never really is random. There's always physics.
Finally, if we go to analyze this curve N12, we can interpret it very nicely. We can interpret it as a sum of two curves, which I will draw here. You see, that's why I need the blackboard, so I got several cases. So I draw two curves here. One which would represent what I call N1, the number which would come if hole number 2 is closed by another piece of armor plate in front, and so they all come through number 1. And
so you can understand that obviously there'd be no separation. A millimeter apart at a distance can't produce two separate things in separate locations because it's only a millimeter apart. So this is like basic, he's an expert on photons and he's not getting the fact that no, I can't have 2 point sources and I can't make them create light over here and light over here. I can't make them do that. It's impossible. Even if they're shooting in all kinds of different directions and I try to sense their separation, I can't do it. It won't happen. The two humps are going to be 1 millimeter apart. That's the best you can do. Can't do any better than that.
N2 would be the number that comes through hole number 2 alone. So N1 is the number that comes through hole number 1 alone, and N2 is the number that comes through hole number 2 alone. Those numbers being determined by closing the respective holes. And then we discover...
So I'm just saying this is a huge, this is where he's taking the actual truth and this is, bending it to create a diagram that will justify some notion that there's separate things happening in these two openings and that they need to be randomized because they're creating these kinds of outcomes. And it just isn't the truth. So if we drew those two clumps on top of each other and said, look, they make light on the wall, and it's a little tiny bit difference between the two openings, and then showed what the photons actually do, okay, which is create the pattern. And the pattern just means that you've created out of phase positions and in phase positions. The same energy's hitting the wall. The places where the bits of energy are in phase and recreate a frequency that can be recognized as light, you see those. You don't see the ones where it's out of phase. But no light is doubled and no light is destroyed. There is no destructive interference. There's no interference. Photons don't interfere with photons. There's absolutely zero evidence that you can bang a piece of energy into, the fundamental energy, anything moving the speed of light, that you can bang something moving the speed of light into something moving the speed of light. No experimental evidence that that's possible.
A very important law, which is that the number that arrived with both holes open is the number that arrived by coming through number 1 hole plus the number that comes through number 2 hole. And this proposition, the fact that all you have to do is add these two together, I call nice, or no interference. That is, what you get from the 2 holes open is the same as you get by simply adding each hole separately. That's the bullets done. We're done with bullets.
All right, so the change for light is going to be the squiggly line. So that's going to be it. So the same basic argument.
All right, I begin again. This time with water waves. Here is standing some kind of a big mass of stuff which is being shaken up and down.
All right, so this water wave comparison goes back to Young, and again is simplistic, and the comparison in terms of it's not really honest. Okay, the water in each location is going up and down in the constructive location. It's going up and down, up and down, up and down, up and down. It's moving. Okay, it's turning on and off. Unlike in the photon example where it's either all on and stays on or it's off. And so the pattern's being made out of on and off locations, where in water waves it's moving, not moving, moving, not moving. Really different.
This is a long line of barges or jetties with a gap in the water in between. Perhaps it's got to do with ripples and it has to do with big ocean waves that sound more sensible. Wiggle my finger up and down here, and I have a little piece of wood here, and ripples start out here, and then I've arranged in a tank to put boards in the way here, so that I have these 2 holes. And then I have this so-called detector, and what I do with the detector, what the detector detects is how much the water is jiggling. For instance, I put a cork in the water and measure how it moves up and down, and what I'm going to measure, in fact, is the energy of the agitation of the cork, which is exactly proportional to the energy carried by the waves.
So again, the irony is, okay, in the future lecture, 15 years later, 17 years later, whatever, he's basically going to argue that this wave comparison just distracts you from the truth. It's a dodge, don't pay any attention, because it doesn't work. It doesn't work that way, okay? Photomultipliers don't work that way. The instruments that measure photons don't work that way. So, so he's using, wave theory as a defense, and later he's going to say, I wish they didn't teach that, and he was guilty of teaching it.
Also, I forgot to say that this jiggling is made very regular and perfect, so that the waves are all of the same spacing from one another, and then I'll describe what we get under those circumstances. For that, I first remark, well, let's see, first, we can measure the energy of the cork, but then another thing is important for light, or for water waves, is that the thing that we're measuring can have any size at all. We're measuring the intensity of the waves, or the energy in the cork, and if the waves are very quiet, if the fellow over here is only jiggling a little bit, then there'll be very little motion of the cork, and so on. No matter how much it is, it's proportional. So, it can have any size. It doesn't come in lumps.
And obviously he's going to say photons don't do that.
It's not all there or nothing. And what we're going to measure is the intensity of the waves, which, to be precise if you want, is the energy generated by the waves at a point. And now what happens if we measure the intensity, which I'll draw on a third curve here, which I'll call I to remind you it's an intensity and not a number of particles of any kind, and I12 when both holes are open is a curve that looks something like this. An interesting, complicated looking curve, which ought to be symmetrical. Very complicated looking curve.
All right, so this is the key point. So this is the single slit pattern. It's not the double slit pattern. So, you should just understand that this doesn't have the key features in the photon double slit. This is the wave double slit. Okay, this is what the wave double slit does, because the wave double slit doesn't do this key thing. Okay, so the big giant omission, okay, what they haven't paid any attention to, all right, is this right here, these little empty spots. Okay, waves don't do this. So in the double slit pattern for waves, no matter how big you make the openings, no matter how small, no matter what you do with them, okay, they don't create these two little dead spots here, you know, and a dead spot here and a dead spot. They don't create the double pattern. This is called the envelope pattern. You know, this pattern on superimposed on top of this dot 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 pattern. Water waves don't do this. Okay, key feature, and it's missing. And like I said, it doesn't matter how big I make the openings, doesn't matter what I do. I can't make water do it because yes, what water's doing is making a wave come out of the, it's making a wave coming right out of the opening. And the key thing that makes it clear that light's not doing that is the fact that light does look different. It does this instead. And this is not this. Okay, the two patterns aren't the same thing, and they're not the same thing for a clear reason. And the reason is these waves have nothing to do with it. It's a point source, like a little lighthouse on each one of these peaks, and the lighthouse is shooting rays in every direction. And guess what? There's a 50-50 chance that any one of these rays will be either heading for being in phase or heading for being out of phase. Okay, it's a 50-50 chance that your photons, when they hit, that they'll be restoring the phase or they'll be broken in phase. A 50-50 chance, and that's why you get the pattern. It's because you basically, and you know, frankly, these light spots are a bit bigger. So it's more like a 60-40 chance. But regardless, it's clearly point sources. The surfaces are the experiment. There is no wave.
If we put the thing in different places, we get a very, very different intensity, which varies very rapidly in a peculiar manner. And you're probably all familiar with the reason for that. The reason is that the ripples, as they come out of here, have crests and troughs spreading from here. And they have crests and troughs spreading from here. Now, if we're at a place which, say, is exactly in between these two things, so that the two waves arrive at the same time, the crests will come on top of each other, and there'll be plenty of jiggling. Which is
right, and that'll be inside, in the case of a photon, 1 millimeter. So all of that energy has to happen inside of 1 millimeter. You can't, there's no other place. It all has to happen inside of 1 millimeter. Clearly the bright spot in the pattern is a lot bigger than 1 millimeter on the screen. So obviously that's another fake. Another thing that a scientist should be able to, it should occur to him that, oh, I can't really talk about what the center node has to be because that's inside of 1 millimeter and I'm looking at a pattern that's a foot long. Obviously that would be ridiculous.
the exact opposite of this curve. So I'll have to put, there should be another bump. We have a lot of...
Yeah, so, but that's how sloppy the whole drawing is. That's how sloppy he takes the pattern. So the huge difference between the single slit and the double slit pattern, hugely different in appearance, huge difference. And none of that's paid any attention to, so he can tell this fable. So he can make this comparison between water waves and light and imply that the same effects happen, that the waves bang into each other and combine into a new thing, when we know photons don't do that, and gravity doesn't do that, and all the forces don't do that. They don't combine into new things. They're independent forces, okay? I put 10 magnets in a circumstance, the magnets don't combine, they don't do any of the math, okay? They have to hit something, and the math is done independently for each magnet, or for each gravitational body, or for each piece of surface that's going to get hit by photons. Photons don't interact in space and construct or destruct. They have to get to the surface, and the surface does the math. That's a key argument in this physics. That's a key point. That's a Newtonian law kind of point. That none of these forces, okay, can do anything to each other. The only thing they can do is affect a piece of matter, and they all have to do it independently. Individually. They all individually do their bit. And if you get an outcome, the outcome is made of those individual contributions.
Jiggling right in dead centers. On the other hand, if I were to move to some point here, since I'm further from hole 2 than hole 1, it takes a little longer for the waves to come from 2 than from 1. And when 1 has a crest arriving, the crest hasn't quite reached there yet from 2. In fact, it's a trough from 2. So the water tries to move up and it tries to move down from the influences of the waves coming from the 2 holes, and the net result is it doesn't move at all, or practically not at all, and so we have these low bumps at that place. And then if you move still further...
Right, and again, photons aren't doing any of this, okay? There's none of this has anything to do with it. It's just two dot, dot, dot patterns. I can have dot, 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 and then I can have dot, 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 you know, and they could be out of phase. And if they're out of phase, then they're going to be dot, 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 right? They're going to be some other pattern when they hit the surface. The surface isn't going to hear dot, 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 and dot, dot, dot. It's going to hear dot, 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 dot. Yeah. And it's that simple. Nothing happens in the space getting to the surface. The surface will decide whether they're in phase or out of phase.
Over, you get enough delay that when a crest is here, this other crest is in fact one whole wave behind. So in fact, it's a crest that two crests are coming on top of each other, but not the same crest, so to speak. The fourth crest from here and the fifth crest from there on top. So you get a big one again and a small one, a big one, small one, depending upon the way the crest...
So just in phase, out of phase, and again, I can answer that with scatter. I can take any Morse code signal, okay, and I can send it in, dot, 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 right? Same frequency. I send that in, and it's disrupted. It's scattered in all directions. The fact is, it will take it longer to get to a location. You will have difference in timing of when something lands. But the fact is, half the time I'm going to get dot, dot, dot back, and then half the time I'm going to get dot, 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 you know, where it's all out of sequence. It's out of phase. So if I put it out of frequency, okay, the radio receiver isn't going to receive it. So again, I could point to radar experiments that demonstrate that the geometry for wave interference is exactly the same as the geometry for jamming a radio signal. They're identical. It's identical mathematics. Do they tell you we're just jamming? No, they pretend, okay, that the waves are interacting with each other and all kinds of shit is happening. So I have two radio antennas, and if they were flashlights, I know I can't make the flashlights interfere with each other. I can't shoot the beams into each other, have them interfere and create the pattern. But somehow a radio antenna can. They're the same photons, technically. It's the same mechanism. It's just a lower frequency. So all I've done is lower the frequency with two antennas. And yet, the fact is now it looks just like I just jammed the radio signal. There's no evidence that I've done anything other than just jam the tuner, the receiver. The receiver can't receive it. If I send two signals out of phase, it won't know which one to trigger on. It can't see the two signals. So it'll say there's nothing coming in. When, no, there is. There's plenty of energy hitting the antenna. It's just you can't see it. You can't tune it in. You can't tune in either radio station. So do you think if there's two competing radio stations that they're not the radio stations when you can't hear anything on your radio? It means the two radio stations aren't producing energy? No, it just means you have to move your car over a little bit and all of a sudden you'll receive both of them right on top of each other. Because now they're in phase and your tuner can tune into the signal. See? The energy's already going to the surface. It's all hitting the surface. All the energy gets to the surface. And all you're saying is some of it's in phase, some of it's out of phase. Nothing's been destroyed, nothing's been created. That's real physics. So I could go on, but we'll draw a point and just say this is probably enough to illustrate the point. Okay, the point is, well, I'll just show it. There's nothing in this Feynman drawing that has anything to do with the real double-slit pattern. He's not doing the double-slit pattern. He's doing the single-slit pattern, and he's doing it badly. And that's the big lie. Okay, this is not the character of physical law. This is not how the universe works. What he's talking is a mistake. Okay, it's an error. It's not accurate. It's not the truth. It's not rational analysis. It's not good detective work.
Crest and troughs interfere, as we say. The word interference, again, is used in science in a funny way because we'll have what we call constructive interference. When they both interfere here, it makes it stronger. Well, they call it interference anyway. But
So yeah, yeah, that doesn't make any sense, right? Yeah, no, it doesn't make any sense. It can't make it stronger. It can't do this. It can't. Yes, there is no creation and destruction of the force. So you're stuck with you're stuck with a rule that says your explanation is already invalid because it's violating a rule you know is really reliable.
the very important thing is that I1, 2 is not the same as I1 plus I2, and we say it shows interference. Yes, interference. That's a funny term we use. Constructive and destructive.
All right, so I'm just saying he's just going to say, okay, so he did bullets, he did water waves, and then he's just going to say, yeah, light does this, but he's not going to fix it at all. He's not going to do the real double slit pattern in any way. He's just going to say, see, it must be like the wave thing. All right, so really, that's probably enough. Yeah, now well, anyway. So yeah, I like Richard Feynman, interesting character, but the physics is crap. It's crappy physics. It's crappy science. All right. And as much as I think he loved science and he loved being respected as a smart person and a serious person and all of that crap, he was more show than go, frankly. And I think it was more about his ego than it was the truth, frankly. Okay, unlike Einstein, who threw away a lot to fight for a better answer than wooey, spooky action and random universe bullshit. Alright, so anyway, this has been draftphysics.com, also debatephysics.com, but nobody will debate any of these arguments. They'll just say something like, you're full of crap. Yeah. Alright, anyway, nothing about the specific arguments. There'll be no counter to the specific arguments made in the video. Nothing. Anyway, so till the next time and such. This little animation in the background, this is how it really works. Okay, nothing destroys, nothing. It's all each little bit of energy in the universe has a very, 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 very long history. It's been lots of places and done lots of things. So anyway, till the next time.